Hey, on today's lesson, we're going to write equations to model data. This page is in your textbook. It's actually page 78 of your book. Okay, but I want to just point out something that I don't know how many of you know, and you don't necessarily need to get a book out or anything like that. This is just information, FYI. If you're looking at a table and you want to know whether or not, like if you're given something in table form, most of you in equation format, you know if you have y equals x squared, you have a variable squared, it's a quadratic. Versus if it looks like this, it's linear. Okay, so you have your quadratic, you have your linear. All right, well, if you're looking at it in table format, most of you know that a linear, this is x, this is y, that's 1, that's 2, that's 3, this would be 2, 4, this would have to be 6, okay? As x increases by a constant, y also increases by a constant. Okay, well when you're looking at, by the way, this is called a first degree pattern. You're adding 2 every time. You guys with that? Okay, now I could have continued that pattern. When you're looking at a quadratic, it's a second. You look at the second differences. So if I have equally spaced x values, like when you've dealt with linear, you go to your y values, subtract 5, subtract 3, subtract 1, or add 1, add 3, add 5. Okay, or excuse me, add. Okay, from here, if you go from here to here, you're adding 2. Here to here, you're adding 2. If you can get to the second difference and it's constant, that means you're looking at a quadratic relationship. Okay? Now, how many of you already knew that? Okay, now let me just point out what I'm talking about. You know, everyone in here knows this table. Okay? Right? If this is 1, this is 1. This is 2, this is 4. This is 3, this is... Okay. Now, and we can keep going. Oops. Except for you'd have to put the right number. So let's say 14, 4, 16. So here we're adding 3. Here we're adding 5. And here we're adding. And we can keep going. Notice, when you get down to the second degree, it becomes constant. Or the second level, it becomes constant. That means this is a quadratic relationship. And you already know this is quadratic, but it's not always that easy to look at and know it's quadratic. So that's what I'm saying. Is like, look, if you want to test a table, do that, and you can find out. Now remember, these have to be equally spaced, meaning they're going up by the same amount on top. Okay, how many get what I'm saying? Okay. So that's really what this is saying, and I really think that's important stuff to know. If you look at the second differences and they're constant, then it's a quadratic relationship. Very good? Okay. So with that being said, I want to take a look at your exploration number 2 on page 39 of your student journal. And in order to do this one, in order to do this exploration, we're going to work through it together. But just so you believe me, you don't think I'm lying about that second degree thing, or the second level thing, I keep saying second degree, I want you to calculate this difference. Okay? Make sure it's quadratic. I mean, they say, well, they don't actually say it. It says to make a quadratic model, but it's nice to actually know if you can make a quadratic model out of it. So let's go ahead and calculate that difference real quick. All right, I get minus 16, and then minus 48, and then minus, we got that, 80, thank you, and then minus 112. Okay, and that gives me a second difference of 32 on all of them? Good. So this is a quadratic relationship. Okay, so that's just a quick little piece there. What I want to do is I want to use quadratic regression. Now we've done linear regression. I want to put these two things as lists in our graphing calculator. Okay, it says the table shows the height and feet of a wrench in t seconds after it's been dropped from a building under construction. Use your graphing calculator to create a scatter plot. They've shown us a scatter plot here, but I'd like you to put it on your calculator. So let's call this L1 and L2. Okay, so if you need a calculator, grab one now. And recall that when you're doing this, what are we using? We're going to stat on our calculator. So I use my amazing zoom out feature. Stat on my calculator is right here. We click stat, and we option 1, edit, and under list 1, I'm going to put my time. And under list 2, and then we're going to quit out of that. Okay, how many of you remember how to do a linear regression? Okay, well, let's go. If I want to calculate the regression of it, then what I want to do is I want to go to stat and go to calc. And this time I want to, like, I could calculate linear. Like if I went to number 4 and calculated it, I do it and it gives me this. Now, I could say, well, dude, it's linear. Look, it gave me a 8. Look, it's negative 64x plus 432. That's the equation of this line. Okay. Well, if you have the, how many of you have the diagnostic tool on, where you're getting an R value? Okay. So once again, go back to catalog. So second 0, and notice the A ends up here. So that means the next. Oh, sorry. You can't see it there. At the top of your screen here, there's an A right now. That means, let me see if I can. Okay. That means your alpha key has been hit. It's still kind of hard to see it there. Right? I want to go down to diagnostic on. So diagnostic on means if I select D, alpha D, which is right here. So go alpha D. It'll allow me to go down to D, and I want to find where it says diagnostic on, and hit enter, and then select enter again. You gotta scroll all the way down to diagnostic on. Okay? From there now, if I did go back to stat and select calculate, if I did linear regression this time, option 4, it's going to give me an equation again, but notice my R value is negative 0.95. That means it's really close to linear. You guys with me? It's really close to a negative 1, which would mean a perfect linear equation. So now if I go back and select, let's go ahead and go to stat again. And let's see if quadratic is better, option 5. I go to quadratic, and notice my R squared this time it's 1. It means it's a perfect quadratic, which we already knew because we did this. Okay, that means this is a quadratic relationship. My equation is negative 16. So y equals negative 16 x squared. So that's what our A is. What's B? 0, so plus 0x plus 400. Now we could actually write that as y equals negative 16x squared plus 400. We don't have to put the 0 in there. Okay? So we have our scatter plot, explain why the data appears to be a quadratic fit. Well, you could do a couple different ways. You could talk about your diagnostic tool. You could talk about your second level pattern. Okay? Any of those would work. Or you could look at the picture and go, well, it looks like it's a parabola. Right? All right. Any questions there? Okay, turn the page, please. Look at letter B. It says use the quadratic regression feature to find a quadratic model for the data. Okay? Quadratic regression feature, find a quadratic model. Meaning, if I take my calculator now, I have my quadratic regression. I now need to go into my y equals menu. I'm going to clear out my equation in there. Now my y equals menu, I have to enter that equation. Now you can actually handwrite it in, or like this time, not handwrite it in, you could type it in. Negative 16x squared plus 400. If it was a long equation, you could select your bars feature, which is right here, and then go to y bars, option 1, which is function. Oops, excuse me, that was wrong. Let's go back to bars. Bars, and go down to statistics, and then go over to equation, and it'll type it in for you. Okay? But notice you don't have any of your plots turned on, which means your points aren't going to show up. So you got to go up and turn on your plot there. Okay? And then if you go to zoom stat, option 6, it's going to show your graph. Dude, that didn't help too much there. Oh, zoom 9. Thank you. Zoom 9 is stat. There it is. Pretty cool, huh? Yeah, man. Okay. When does the graph hit the ground? So we're looking at our y values. If you recall, we're trying to figure out when the graph hits the ground, what do we want our height to be? 0. You want, remember, these are your x's, these are your y's. You want y to be 0. So if I go to my table, I can move around. I'm like, holy cow, dude. Look, I'm like at negative feet here. Where does it hit the ground? 5. At 5. After how many seconds? Well, it's 5 seconds, right? Okay, so after 5 seconds, that's when y is 0. Okay. You all right there, Kendall? Okay. All right, how many got it? Hey, really quick. Eyes here. Guys, a couple comments. First, if you go to table set, second window, some of you might be going up not by 1s but by 10s. Make sure you can change that. You can change that under your table set, which is second window. You just change that to 1. Table set. Second window. Huh? No, table start tells you where you're starting. You're starting at whatever number's there. So like, I'm starting at 1 going up by 1. If I put 7 here, I'd start at 7 in my table, and I'd go up by 1. It's up to you. Yeah, like if you're gonna find something in the thousands, you want to start in the thousands. So you might change it to 0. Yeah.
So after you get the graph, how do you
Yeah. Yep. Okay. So, guys, what I'd like to do right now, let's go ahead and take a look at this problem right hither. I want you to use your graphing calculator for that one. First, you may want to figure out if it's quadratic. You don't have to, but you can do that with your graphing calculator as well, using the diagnostic tool. But you guys, these are commas. Commas. Thank you for pointing that out. I'm waiting. Not sure what I'm waiting for.
Oh, okay.
Can I borrow this? And you're all right there? So did you get it in the calculator?
Yeah, I went to bars. I went to number 5 statistics.
Okay.
And go to the regular equation. That brings me back to the table.
Okay. Why don't you bring it here? We'll look at it with you. Hey guys, notice this is quadratic because the second level is equal there, right? This should be a quadratic relationship. That's a fairly quick way to figure out if it's linear or quadratic. All right. Okay, everyone had to get that in there. Let me turn off that light. There we go. Hey, from there, for those of you still struggling, make sure you're writing down your steps. You need to go to you need to go to Stat, Calc, Quadratic Regression, number 5. Okay, notice it's a perfect regression. It has r squared of 1. When you put that into your calculator, you go to your y equals, and then go over to EQ, which is regression equation. It'll enter that whole equation for you. Or if you wrote it down by hand, you could have done that. Sometimes the equations just get real nasty looking. Okay? And then from there, you can hit graph, and it should show you. Yeah, it doesn't show you anything because I have to go to zoom what? Zoom stat, which is zoom 9. And there we've got it. Okay? Now the actual question says, write and evaluate a function to approximate the height at which what occurs? Well, after 20.8 seconds, they experience weightlessness. That's what we want to find. So time is on the x-axis. So I need to find 20.8 in my table. The only way to get your table is to have the equation. So now we can go to second table or second graph, and notice I'm not going up by points. So what I'm going to do is go to table set, so that second window, and I am going to start my table at 20.8. And I am going to go up by 0.2. And then I hit table, and notice at 20.8 it's at 30,801 feet. Isn't that totally neato? Okay,